what are something that you can hear? Maybe something that you can hear when you close your eyes, maybe people talking, and then music playing, or cars going by. Yeah, there are many more sounds you might be able to hear. And then, how are you able to hear the thing? Yeah, so ear give us our sense of hearing, and the vibration go into your eyes and vibrate something, and it's called eardrum. So how are you able to make sound? We can make sound by talking and then singing or playing an instrument. Okay, to make you more understand, let's watch the video.
Like if a sound is really loud and kind of unpleasant, like when there's a lot of traffic going by, we sometimes call it noise. And if a sound is made by an instrument like a piano or a ukulele, we call it a note. And we call lots of notes together music. And some words are kind of like the sounds themselves. Like when fireworks go boom, popcorn pops, and bells go ding-a-ling. It doesn't matter what makes a sound though. All sounds are made the same way, through vibrations. When something vibrates, it moves back and forth really fast. So fast, in fact, that our eyes often can't see it moving. But other parts of our body can sense vibrations, and I bet you know what parts those are. That's right, our ears. So how does sound get from, say, a bell to our ears? The air all around us is made of tiny particles, and these particles are what carry sound. We can use marbles to demonstrate the teeny tiny particles that make up the air. Let's see how. If we put a few marbles together so they're touching, then roll another marble so that it crashes into them, the group of marbles will move. That's kind of what happens with sound. When we ring a bell, we cause the metal that makes up the bell to vibrate really fast back and forth. And the vibration of the bell also shakes up the particles that make up the air around it and makes them vibrate. Then those particles run into the air particles next to them, and so on. You can also think about it like dominoes, with the vibration getting passed along from one bunch of particles in the air to the next. We call this path of vibration a wave. Now, how do we hear those vibrations? If we could look deep inside our ears, we'd see a special little part that kind of looks like the top of a drum. When sound waves make it all the way to and into our ears, they make this part of our ear vibrate. The vibrations keep going, moving even deeper into our ear until they finally get to the spot that sends a message to our brain. And that message says, hey, we're hearing something! Now, who's ready to make some vibrations? We can make a kind of musical instrument that will help us to see the vibrations that we make. All we need is an empty can, like a coffee can, and a rubber band that's just big enough to stretch around the can from its top to its bottom. Stretch the rubber band over the top of the coffee can, and ta-da! We have an instrument, one that's kind of like a guitar. Let's pluck the rubber band gently. Does it make a sound? It sure does. And if we look very, very closely, we can see that the rubber band is moving back and forth. When we pull on the rubber band and let it go, we're causing it to vibrate. These vibrations travel into the air, making the air particles move through the air to our ears in a sound wave. If we pull kind of gently, the sound is kind of soft. But if we pull a little harder, the sound gets louder. And if we grab the rubber band while it's moving and stop it from vibrating, we also stop the sound. Hey, we made some pretty good vibrations. So whenever you hear a sound, you know that something, somewhere, is vibrating. And those vibrations are traveling through the air and into your ears. So thanks to all of you who asked us how sound works. And make sure to check back every week to learn more science with Squeaks and me, and we'll see you next time.
After you learn the previous video, let's continue to learn more about sound.
So, sound is the energy that comes from a vibration, and sound cannot be produced without any vibration. why we cannot always see the vibration that makes sound produced? Yeah, it is because they can happen really fast, sometimes thousands of times each second. If you cannot see vibration, how do we know they are happening? We can make vibration visible in many ways. One of the examples is we can feel our throat while humming. If you put your hand on your throat and hum, we can feel the vibration of our vocal cord. It makes a sound. And then next is there is some properties of sound. It is frequency, and then amplitude and time period. Frequency is the number oscillation per second. The unit is hertz, and the frequency means how frequently the particle of a medium vibrates when a wave moves through the medium. And the formula is 1/period. And the second is time period. Period can be said to be the time taken to do something, and the time taken by the periodic event to repeat. So it's called period. And the formula is period equals to 1/frequency. And then the unit of period is second. The next is amplitude. It is the measure of the height of the wave. The amplitude of a sound wave can be defined as the loudness or the amount of maximum displacement of vibrating particle of the medium. Do you know sound cannot propagate in the absence of medium, and it also belongs to the longitudinal wave because their propagation form a compression and expansion. When the vibration is stronger, the distance will closer to the source of vibration source and the listener. The distance traveled by the sound per unit time, and it's called sound wave propagation or speed of sound. So we can write the formula is V equals to S/T, or it means V is the speed of sound, and then S is the distance, and T is the time. So the speed equals to distance over time, or we can say that the speed equals to distance time 1/time. And in case of sound wave, the distance is equals to wavelength, and the frequency is 1/time period, right? And so we can get the formula become speed equals to wavelength times frequency, or V equals to lambda times f, which is the unit of V or speed is meter per second, and then for the lambda it is meter, and for the frequency is hertz. Let's exercise. When a person shouts and their voice creates a sound wave with frequency of 540 Hz, their voice travels the distance of 154 meters before it is heard by their friend 0.467 seconds later. And the question is: A. What is the speed of the wave? B. What is the wavelength of the wave? And C. What is period of the wave? Okay. To answer their question, for the A, we know that the formula of speed is the distance over the time, and the distance are 154 meter, right? And the time is 0.467 seconds, and we can put it on the formula and we calculate it. The result is 330 meter per second. And for the answer B, to know the wavelength, we have the formula is lambda equals to speed over the frequency. So we have now the speed. It is 330 meter per second over the frequency. It is 540 Hz, and the calculation is 0.611 meter. Yeah, when we talk about the wavelength, it's related with meter, so the result is 0.611 meter. And the last question is the period of wave. We know that the period of wave is T, yeah, and the formula is 1 over frequency. So we can directly answer 1 over the frequency is 540 Hz. It is equals to 1.85 times 10 to the power of -3. And then the next is sound grouping based on frequency. The first is infrasonic, the second is audiosonic, and the third is ultrasonic. Yeah, infrasonic is sound wave whose frequency is below 20 Hz. An example is dog, cats, and crickets. And the second is audiosonic, is sound wave whose frequency is between 20 Hz up to 20,000 Hz. An example is human. And then the next is ultrasound. Ultrasonic is sound wave whose frequency is above 20,000 Hz. An example is bats and dolphin, and this wave also can be used to radar, ultrasound, measure the depth, and then the audiosonic, also called audible, it means it can be heard by human, and the infrasonic and ultrasonic is called inaudible sound. Yeah, the human cannot hear the sound of inaudible range. And then there are several characteristics of sound. There is loudness, and then pitch, and the third is quality. Yeah, as we know that the loudness, we can determine the loudness of the sound based on the amplitude of a sound wave. When the amplitude is high, it will produce a sound that is loud. But when the amplitude is low, it will produce a sound that is soft. So loudness is proportional to the square of the amplitude. And loudness also is measured in unit decibel. And the second is pitch. Pitch showing the sharpness or flatness of sound. Usually we have to know if the woman voice has a high pitch than a man voice. It's because the frequency of woman voice is higher. And then the last is quality. The quality of sound is that property by virtue of which two sounds of the same pitch and loudness produced by the two different musical instruments.
Now, I will show you a simple experiment to demonstrate how different pitch sounds are made. And I have 8 bottles in here, and I wanna use them to make different musical sounds. Are you ready? Let's get started. Yeah, now I have put some water in the bottle, and I will tap on each bottle, and please listen carefully. Yeah, if you listen clearly, you could hear that each musical sound will different, and I will make some song. Can you guess what the song? Why are some of them have pitch higher and lower pitch? Okay, when we tap the bottle using this spoon, it will produce vibration in the bottle, and the vibration will produce some waves. And the bottle that contains more water, it will produce pure vibration, so the sound will be loud. And while if the bottle